As explained earlier when discussing the concept, DCF consists of parts 1 and parts 2. Part 1 refers to explicit cash flow, which is the area analysts forecast meticulously. And next we have part 2 where on terminal value, because it is impossible to make precise forecasts indefinitely. So part 2 covers the roughly estimated area, and generally the ratio between part 1 and part 2 in total enterprise value is balanced to avoid any excessive weighting on either side. It can range from 3 to 7 to 7 to 3, I think, but it all depends on each individual situation. It depends on whether you do a 5-year DCF or a 10-year DCF or a 30-year DCF. It also depends on the growth rate. Are you forecasting a company that's growing at a 20% rate or a 5% rate? It all depends on that, the ratios. But just one thing just to keep in mind, try to keep it balanced as much as possible. Don't avoid excessive weighting to either side. And in this lesson, we're going to learn about calculating terminal value. And generally, there are two methods for calculating terminal value. Number one is the Perpetuity Growth Model. In other words, the Gordon Growth Model. So when people think of DCF, I think this is the method that usually comes to mind. So most of the people are familiar with it. However, there is another method called the exit multiple method. It's kind of like a combination between DCF and trading comps or transaction comps valuation. But I think in most university finance courses, or if you're studying for CPA or CFA, or if you're learning DCF from another education institution, we mostly focus extensively on the first method, and very little is mentioned about the second. Mainly because the first method is indeed more commonly used, because as we will see in a moment, the exit multiple method has some disadvantages in terms of reliability. But nevertheless, we will focus on method number 1 in most of the parts in our courses, but we will revisit the exit multiple method through bonus contents or through YouTube. So let's take a look at the first method. In the Perpetuity Growth method, the concept is that free cash flow after a certain point of time, it grows at a specific growth rate. So this perpetual growth rate is going to be called the terminal growth rate. Since it represents growth that continues indefinitely, it is generally assigned a very small conservative number. Even by using a slightly higher number could result in a overly aggressive projection, and it's going to invite significant challenges. So therefore, when determining terminal growth rates, it is typically assumed that the company has reached the end of its growth, or the company has reached its mature growth rate. And usually the case is that companies experience high growth in its early stages, and it's followed by a slowdown, and eventually they enter a mature phase, where growth rates are very low. So in offline classes, I often ask to students, what percentage would be a very good low number for this terminal growth rate? Well, most of the students do say a very low number. 0 to maybe 5%. And yeah, it is true. I think in most of the cases, we commonly see numbers between 0 to 3% maybe. I think 4 or 5% is going to be considered too aggressive. And maybe 3% is also going to be considered very aggressive. So generally, I would have to say maybe 1 to 2%, maybe 0.5%, somewhere in that range, I think, plus or minus is appropriate. But anyways, the logic behind that is usually it's based on inflation rates or GDP growth rates. So we are assuming that when a company reaches its mature growth rate, now it grows at a very slow pace, similar to something like an inflation rate or GDP growth rate. This is a very conservative approach because you're considering that the company, if you're like thinking about the company's revenue, for example, let's say that revenue consists of price times quantity. We're assuming that quantity is now stable. We're just assuming that price is growing as much as inflation rates. So it's like assuming that there's almost no actual growth. So it's a conservative approach, thus appropriate when making assumptions for something like this. But anyways, let's just remember that these numbers usually fall between 0 to 3%. I usually recommend that you use a number lower than 2%, just in case you receive any significant challenges. But how are we going to ultimately calculate terminal value? So although it is not critical, the principle itself is based on the sum of geometric series. Depending on the country, you may have encountered this in your math classes, or in college. Of course, you don't have to know this principle. What's important is the formula up here. So, assuming we have projected diligently until year 5 and year 6 is where terminal value starts. The formula is as follows. In the numerator, we have the 6th year's free cash flow. And we can see that the denominator is WACC minus the growth rate. But because we don't yet have the 6th year's free cash flow, instead how we calculate this is we go to year 5's free cash flow and multiply it by the growth rate, which gets us to year 6 free cash flow. And it's a formula that's not too difficult to memorize. But of course, in my opinion, professionals in the field, in actual practice, you really don't have to struggle too much to memorize it. You always have Google for that. But if you're preparing for interviews, or if you're a student, I think, or preparing for exams, it's definitely a formula you must memorize. Me personally as well, when I was applying for junior positions or internships, I received this question a couple of times. It's a question where it's very convenient for the interviewers to check your background knowledge in DCF valuations. But for others, what is more important is what this formula means. So if you look at the formula, what happens is, number one, the larger the free cash flow, the larger the terminal value becomes. This is pretty obvious. Number two, it's not the general free cash flow, but it's specifically the free cash flow of year 5 that's important. So, even if you have a very low free cash flow projection for the first 4 years, if you've assumed a very big number somehow in year 5, it's going to result in a significantly bigger terminal value. And secondly, there's a growth rate G. And of course, because it's a positive item on the numerator and a negative on the denominator, the larger the G is, of course, naturally it's going to lead to a higher terminal value. And lastly, of course, WACC for the discount rate, the higher, the lower the terminal value results will be. So I think understanding the formula's implications to this extent should be sufficient. And one additional point is that if we use this formula, whatever terminal value that we calculate, it's the value viewed from the perspective of the fifth year. So you're standing at the viewpoint of the fifth year, and we can say that it's the enterprise value viewed from the fifth year. But we're standing at the present, so if you want to use this formula, we do have to discount it for an additional 5 years. Of course, for those of you who have just heard of this theory for the first time, it's going to be quite unfamiliar. So let us explain this in more detail as we go through the financial model when we actually create our DCF. And of course, for technical interview purposes, I don't think that's too important. So if you haven't understood it, I recommend that you move forward at this point of time. And next, I'm going to briefly explain about the second second method for calculating terminal value. It is the exit multiple method. So remember when we studied trading comps or transaction comps, and what we're going to do is we're going to imagine that, again, we're going to ride a time machine. We're taking a time machine to year 5, and let's imagine that we're doing a comps valuation at year 5. So what kind of numbers we need is we need the EBITDA of year 5. And if we can assume the EV/EBITDA multiple, the estimated EV/EBITDA multiple in year 5, we can simply multiply these two and come up with the enterprise value viewed at year 5. And what we're going to do is we're going to discount it again 5 years to the present. And that gets us, to something very similar to the terminal value that we've calculated using the perpetuity growth method. So if you hear about this method, and even personally I did as well, it might sound much more appealing. But the problem is that when you actually try to apply it in actual practice, there's a significant challenge when assuming EV/EBITDA multiples. So because we already have the EBITDA numbers for year 5, we already have forecasted this. The only mission is to assume an appropriate number for the multiple. But, this is very tricky. I mean, it's even tricky to come up with an assumption in the present, as we've experienced. But it's even more trickier to estimate what it will look like in year 5. Personally, I think in most industries, it's almost impossible. But, in case if the industry's multiple has historically been very consistent every year, and those industries are usually industries that is already mature in their stage of growth rates. For example, consumer goods or financials, telcos, and so on. Maybe those kind of companies, the exit multiple method might be applicable. But in industries like IT, biotech, electric vehicles, using the exit multiple method, it's going to be way more challenging. But even so, I think if you have sufficient time, I think it's worth it to attempt both methods simultaneously. Or alternatively, if you find that, assuming the EV/EBITDA multiple feels burdensome, you can treat the enterprise values derived from both methods as equal. So you can, for example, calculate the first terminal value using the perpetual growth method, and you put in like 1 or 2% growth rate. And for the second, we reverse engineer the EV/EBITDA multiple using the given EBITDA, because we already have the EBITDA, we can recalculate the EV/EBITDA multiple, and this concept is usually referred to as the implied exit multiple. So it tells you how much multiple, in multiple terms, you're assuming given the estimated or assumed growth rate, terminal growth rate. Of course, if any part of these seem unclear, I will be preparing an additional content going to Microsoft Excel in the future to cover the exit multiple method, just for better clarity. It's a much more simple concept, but I think explaining this solely in words and via PowerPoint is not sufficient enough. But anyways, we've learned the two methods for calculating terminal value. I think in most practical applications, or if you're preparing for interviews, I think more than 90%, I think it's focused on the first method. So I think you should more concentrate on that method for now. Moving on, let's cover a little bit about the forecast years.